Hey everyone, Johnny here and welcome to a new video. Today I'm going to be explaining my process for tackling any question where you're required to find a missing angle or a missing side of a triangle. Now, it's not to be assumed that the triangle will be a right-angled triangle or a right triangle, as some say. We're not assuming that. It actually could be a right-angled triangle or a non-right-angled triangle. So we're going to explain the processes and the methods that we use in both of those situations and the order in which you would go through these steps and these tests for which formula or which equation is the correct one to apply in a given situation. But before I do that, if you haven't already, please subscribe to the channel. Hit the bell for notifications, and if you enjoy the video, make sure to like, comment, and share. Okay, so when you get a question where you're required to find a missing side or angle of a triangle, the first question you ask yourself, and this is the critical question, is the triangle a right-angled triangle or not? If it is a right-angled triangle, we come over to this side of the sheet. If it isn't a right-angled triangle, we go and apply these tests on this side. So let's start with the situation where it is a right-angled triangle. So if it's a right-angled triangle, let's ignore this side here because we would apply two different formulas in that situation. You don't do the same formulas or the same processes in both cases. So assuming you have a 90-degree angle in the triangle, usually represented by a box, sometimes it isn't and you will have to fill it in. But assuming there's a 90-degree angle, a right angle, then the next question you ask yourself is, am I trying to find a side or an angle? What's missing in the diagram? What does the question want me to find? If they want me to find a side, we go down here. We then consider whether we want to use Pythagoras' theorem, what I call Pythag for short, or this acronym here, SOHCAHTOA, which is where you use sine, cos, or tan, and you create an equation to help solve for that missing side. So, again, the situation so far is we have a right-angled triangle, yes, we're finding a missing side, not an angle, and so we have two options. Now, Pythagoras' theorem is given by the equation here, c squared equals a squared plus b squared, and c squared represents the hypotenuse. That is where you can see the missing x in this case. And how you will know where the hypotenuse is it is the side opposite to the right angle. So you can see that if I actually got the corner of the box there and pointed and create an arrow there, I'm pointing in the direction of that corner of that box there, it will point to the longer side of the triangle, which is called the hypotenuse. So x is the missing side, which is the hypotenuse here. So to find that, we would use c squared equals a squared plus b squared, where A and B represent these two short sides. They're called the short sides. It doesn't matter which one represents A or B, as long as you don't get them confused with the hypotenuse, the longer side, which in this case is X. Okay, so when would we use Pythag? Well, clearly it's when you have two other sides. It's when you know the two other sides and you're trying to find the third side. So remember, if you're trying to find a side, the next thing you want to ask yourself is that, what do I then know? What is the information that the question gives me? Well, if it gives you two sides, so if it gives you two sides, if you are given two sides, then you would use Pythag to find the third side, and you can use c squared equals a squared plus b squared, or you can use a variation of that where we rearrange that equation there. We actually move b squared here to the other side to isolate a squared by itself. So this second equation here that you can see me underline is a rearrangement of that. And that's just to save you time. It's a shortcut to help you find the short side. So if instead of x being on the hypotenuse there, it was where the 4 or the 3 were. So if you didn't know one of these short sides, we would use this version of the formula where A represents the short side that you don't know. And you would simply fill in the rest. You would fill in the C with the hypotenuse and B with the other short side that you do know. And just make sure that when you get to the end of the formula here, whether you're using the C squared version or the A squared, so remember this is for the hypotenuse, you use C squared, and if you don't know the short side, okay, or one of the short sides, you would use the A squared version. make sure at the very end when you get your answer, you square root the answer. You have to square root the answer in both cases, because what you're actually finding is c squared and a squared. You're not finding c and a. So you will then have to square root both sides to actually leave you with the side you're trying to find. Okay, what if they don't give you two sides, but they give you one side and one angle, and you have to find the other side? Well, if they give you one side and one angle, like you can see here, 30 degrees is the angle and 3 is the side. See how I don't get a second side? I don't get two sides, so I don't use Pythag. I instead will use SOHCAHTOA. Now, SOHCAHTOA is just an acronym that you should memorize, and you should say it a lot out loud. And it's basically there to help you remember that depending on the situation, depending on the information that you are given, you will either have to use sine, which is the S in so, cos, which is the C in car, or tan, which is the T in toa, to help form an equation and find that missing side. So let me give you an example here. See here how we have the angle 30 degrees? What you want to do straight away is work out what other information you are given. Well, first of all, we're given the side that is right next to the angle. See how the angle attaches? You should always draw this little curve, this arc on the angle, and see how it attaches to this side here. Well, because this side is not the hypotenuse, because the box will point to the hypotenuse, which is over there, and because it's next to the angle, it's not opposite the angle. This side over here is opposite to this angle. We call it the adjacent, right? So in this particular example, we are given the adjacent side. And what we're also given, or rather what we're given to find, is the x here, which, because it's the opposite side to the 90-degree angle, it's called the hypotenuse, which is the longer side of the triangle. So we are given those two sides, right, to help us end the angle. We're given an angle and the two sides, but really you're given one side and one angle to help you find this other side. And because we know the adjacent and we're trying to find the hypotenuse, do you see how it makes the A and the H sound? R. And because R corresponds to car in that SOHCAHTOA, we actually are going to use cos to make an equation. And when you do that equation, you would go down here and you would use the cos one. This is just in this example because we're given the A and the H. That's why you're using cos, because it says that if you can make that sound R, you do car, which is cos. So you would make cos 30. You always put an angle next to the sine, the cos, or the tan, because they're not numbers in themselves. They are just trig identities. They're ratios. And they can actually only have a value if you put an angle next to them. So we would use the angle that we're given to put it next to cos. Again, we're using cos because we were given R, and car is the sound that related to it. If it was O, we would have used sine here. But we're doing cos 30 equals, and then notice how important the order is here. Because it's car, because it's not ha, that's a laugh. So because it's R, AH, you actually will do A first in the fraction. So they call them trig ratios because a ratio is actually the same as a fraction. You can express a ratio as a fraction. Okay, so you can see that here. A ratio is a fraction, and these sine, cos, and tan ratios can be expressed as a fraction. And when you do the fraction, you need to make sure that they're in the right order, and the order is based on that sound. So as I said, it's AH, not HA. So because it's A goes on the top. Whatever letter comes first in SOHCAHTOA is the one that will come on the top. And then the second one, the H, goes on the bottom. So if I then want to apply this to our situation here, I would write cos 30. I would write cos 30. I'll do it down here. Cos 30 equals the adjacent side, which we said was 3, over hypotenuse, which is the thing we're trying to find, which is x. So you see we have an equation. So SOHCAHTOA helps you make an equation because you do cos, sine, or tan of whatever angle you're given. Then you do an equal sign, and then you do a fraction in the order that the acronym gives you here, okay? You make the fraction using that information, and then we would use our knowledge of equations to get x by itself, right? We would rearrange this equation to get x by itself on one side. I won't do that in this particular video, and then that would give us the missing side. Okay, great. What if you got a right-angled triangle? So right-angled still. You needed to find an angle, though. We now know how to find a side. It's either Pythag or SOHCAHTOA. if you need to find an angle, I'll give you the one very basic situation that sometimes comes up that people forget about. It's that you may be given another angle. So if you need to find one angle and you're given the other angle, so you actually know an angle plus the 90 degrees, you know two angles really, but we already know there's a 90-degree angle because it's a right-angled triangle in this situation. If you're given the other angle, so in this case I've done 30 degrees, well, you don't forget that that box represents 90 degrees. So you were given 90 degrees and 30 degrees. So you simply use the fact that three angles in a triangle, the three angles must add up to 180 degrees to help you find that missing angle. So it would be 180 minus 30 minus 90. Don't forget that the box means 90. So you're actually given two angles. So once you subtract 90 and 30, you'll be left with 60 degrees. So I already know the missing angle without having to do anything else because I was given that second angle here. But the more common situation is where you're given two sides. So you need to find a missing angle and you're not given another angle. You're only given the 90 degrees and you're given two sides. So if you're given two sides and you need to find an angle, as in this situation, the green here is meant to be theta. It's just a symbol. It could be X or A. It doesn't matter. If you're trying to find that missing angle, you need to look at the relevant sides that you have and again apply the test, SOHCAHTOA, to figure out which equation to make. So you start by putting your pen on that angle here. So the angle's down here. And then you assess the information that you have relative to that angle. So see how I draw a line here? It's always useful to do that. I get this. I'm trying to find this angle. And what do I know? I know the opposite side. I know the opposite side. So I put an O there. And I also know that I don't get given here the hypotenuse, because remember, you have to just look at this side that is opposite the box. See, the box will point to the longer side. We don't get given that. What we get given instead is 3, which is next to the angle, so that is adjacent. So even though the hypotenuse is technically next to the angle as well, it's on the other side, the left side, because it's the hypotenuse, it's not called the adjacent side. Okay, so you can see the two letters, O and A. Which one do they correspond to up here? So, Ka, or Toa? Well, Oa. OA is where they fit in. They don't fit into O or Ka, So or Ka, I should say. We don't know the hypotenuse. So we are going to apply T in this case, which represents tan. So what you would do is you would then form an equation. We would then write tan of the missing angle equals the opposite. Remember, we have to do it in order. The opposite over adjacent. Okay, so we would do tan theta equals opposite over adjacent. I can't do adjacent over opposite because that's in the wrong order and that won't give you the right answer. What we then do is we write tan theta again and we fill in the O and the A. And in this case, the O and the A are 4 and 3. Okay, so if we have 4 and 3, tan theta equals 4 and 3, we would then try and find the theta here, not by dividing by tan away, because we're trying to get theta, which is the missing angle, by itself, right? You want to get that by itself in the equation so that you can see what it equals. But to get rid of tan, you don't divide by tan because tan is not itself a number. Instead, to move it, you use a function called inverse tan. Or down here, you can see it's inverse sine, but we're applying tan here. It's the same thing though. So in your calculator, you would then put shift, then hit tan, or then hit sine, or then hit cos. And that will actually give you what's called inverse tan, or inverse sine, or inverse cos. And you want to make sure you then put in brackets everything that was on the other side, and then that will produce the answer for you. And that's how you find a missing angle. Okay, so SOHCAHTOA, that's how you find an angle. Make sure you remember to do inverse of tan, sine, or cos, whichever the relevant one is, based on the information you're given. Okay, so that's how you deal with right-angled triangles. You can find any missing side or angle using those different formulas. Okay, those different approaches, which are all based on the different situations. So make sure you do some practice to get used to that. What if we don't have a right-angled triangle? What if instead of being right-angled, there is no right angle? There's just angles other than 90 degrees. So a shape looking like this. Okay, we're still dealing with triangles, of course, but there is no 90-degree angle like you can see there. Well, in that situation, the first thing I recommend doing is not to ask yourself whether you're finding a side or an angle, But the first thing I do is test whether the sine rule applies. Okay, and the sine rule is a rule, it's an equation that will help you find the answer, which is given by a side, which we'll call A, divided by sine of the opposite angle. So you just, for instance, see this diagram here. When I say A, that could be X. See how that is a side length? And then what you do is you divide it by sine of the opposite angle. So what angle is opposite X? Well, if you look at it, it's actually opposite 30 degrees here. Okay, that's 30 degrees down there. And it's important that I'm drawing in a line. See, I'm drawing in a line connecting the side and the angle. This is how you test for whether you can even use this rule. But the point is, you would divide the side by sine of the opposite angle, and then you would make that equal to another side. For instance, 12 divided by sine of its opposite angle. So to use the sine rule, to test for it, okay, I'm going to show you the test. You can't always use the sine rule. That's why I've got a question mark. But if you do use it, you are just basically making one fraction equal another fraction in the way that I just showed. And you can arrange that fraction in two different ways, depending on whether you have a missing side or a missing angle. So these are the same formulas basically, but you can see here the sine and the side are flipped in this situation where we want to find the angle. And the reason for that is because when you're finding the angle, we want it to be on the top. I don't want to be finding the angle and then having on the denominator because it's just more work for us. You could still get to the answer, but it's easier to find something and get it by itself in an equation when it is on the top, when it is on the numerator of a fraction. So that's the reason we have two different approaches here, but they are the same formula, and you could get there just using the top. It would just be a couple of extra steps. So when can you use the sine rule? Because it's not automatic. Just because your triangle is not a right angle doesn't mean you use this formula, because you might not have enough information. So what you do is you look at the triangle and you do what I said. The first thing you do is you're looking to draw a connection between the sides that you're given, including the side you're trying to find. So in this case, the X is a side that I'm given. And I then connect it to the 30 degrees because I'm given 30 degrees. And then the other side I have is 12, and I can connect that to the opposite angle, which is 120 degrees. So do you see how when I drew those two lines, they crossed each other? They crossed. They formed an X. Can you see that letter in there? There is a cross. So what I'm basically getting is I'm getting two pairs of opposite sides and angles, which when I draw a line connecting those pairs, form an X. So if you get an X, you can use the sine rule. Okay? But if, for instance, you weren't given that 12 there, but instead you were given 12 on the other side, so see this missing side that we're not given, if this 12 here was on this side, then it would not connect to the opposite angle because we're not given the angle there. So even though we would be given that side, you wouldn't have the opposite angle. You wouldn't be able to draw a line connecting it to another angle because there wouldn't be an angle. So you don't draw the line there, and therefore you can't draw the X, and so you wouldn't be able to apply the sine rule. And if you can't satisfy this X test for the sine rule, and again, you just apply it in the way I showed you here, and I'll show you an example in a second, you would then go down to the cosine rule, which is a V test. But quickly showing you an example here of how to use the sine rule. What am I trying to find here? I'm trying to find a missing side, so I'll use this version of the formula. Again, they're the same formula, just flipped, okay, based on whether you're finding a side or an angle. Because I'm finding the missing side, I would simply do X over sine, and now I have to put the angle that's opposite the X, which is 30 degrees. So I do X over sine 30 equals 12. I have to put the other side up the top. I can't put the angle at the top now. It's got to be consistent, you can see in the formula. 12 over sine of the opposite angle to 12, which is 120 degrees. And then what you do is you get rid of sine 30 by multiplying it by both sides, because what you do to one side, you have to do to the other, and that will leave you with just X by itself. So you will end up with 12 times sine 30, because that technically is times in the top, over sine 120, and that will give you X by itself. When you put that into your calculator, you'll get the answer. So that's how you use the sine rule. But what if that X wasn't satisfied? What if you got information in a different order? Well, what you then do is you go down to cosine rule. And you would say, hey, if the sine rule didn't work, maybe I use the cosine rule. And you test it by looking at the triangle and seeing if a V shape emerges with the information you're given. So have a look here. See I'm trying to find x in this first triangle, and I'm given 5, 7, and that angle 120. Now have a look. I can connect, see how I can connect these two, x and the opposite angle? Can I connect another side, such as 5, to its opposite angle so I can draw that line and make that cross? No, because there is no opposite angle given to the 5. And there is no opposite angle given to the 7. You can see you don't have that information, so you can't form that x which is needed to do sine. So that's why you can't use the sine rule for this particular triangle, because I can't draw in an x. I don't have enough information. I would need one of those angles so that I could join it up. But I can't join it. There's only one pair that joins. Instead, what I now turn to is the v-test. And the v-test is simply looking at the sides you have. So I've got the 5 here. So notice I'm just drawing this line over the 5. I then get this angle. I get the 120. And then I get the other side. So notice how there's this kind of V shape if you look at the outside. I'm given that side, and they're next to each other, and the angle in between. So a really crucial thing to look for is, are you given two sides and the angle in between? Sometimes they call it the included angle because it's included between them, okay? So it is the angle between two sides. Between the two sides. And it creates this kind of V if you were to outline the information you're given there. If that's the case, you use the cosine rule. And if you're trying to find a missing side, you use this version of the cosine rule. So just like with the sine rule, there are two versions for the cosine rule. They're the same formula, just rearranged. So it can save you time if you're finding the angle to use a different version. But in any case, if you're finding the side, it is c squared equals a squared plus b squared minus 2ab cos c. And remember, cos c in this case would be cos 120, because the capital C here is the angle opposite the side you're trying to find, which is the x. Remember, it's not called the hypotenuse because there's no right angle in these situations. Just remember that when you enter in the numbers into this formula, so the example here would be x squared, we would write, I'll do it down here, we would write x squared equals, I'm applying this formula here, a squared, it doesn't matter what is a out of the 5 and 7, either one, just it doesn't matter about the order. 5 squared plus 7 squared minus 2, and I would put this in brackets just to be careful with it because they're all multiplying each other now, which means you do them first. 2 times 5 times 7 times cos 120. Again, cos C is cos 120 because the 120 degrees is opposite the side we're trying to find over here. Just remember that once you put all of that into your calculator, you then have to square root the answer. So whatever all of that side comes out as, you square root it because you only found x squared, but we're trying to find x, so you have to square root. Just like with Pythag, when you do that formula, you have to square root at the end. The other version of the formula is where you're given 3 sides. So if you are given 3 sides, you know all 3 sides. If you know all 3 sides, so there is the V, really, including the angle that you're trying to find, you still satisfy that V test, technically, because you're given the 5, the 7, and you're trying to find the angle in between, but you also then need to know this side on the outside. So instead of it being a missing side, it's now 12. Now we don't know the angle, and the angle isn't going to be 120 degrees necessarily, because we don't know that the x there was even 12. So this is a different combination. And then what you do is you use a different version of this formula up here, which you should just memorize. And you can see that it's just a rearrangement of the formula to give cos C, which is this missing angle. So it would be cos theta. We would actually write cos theta if we were applying this, because that's the angle we don't know. And then we would say it equals 5 squared plus 7 squared minus 12 squared. You minus the one that's opposite. And then divide it by 2 times A times B, which is 5 and 7. Again, it doesn't matter which one you call A and B in the formula. What you then need to remember to do is to do inverse cos when you're actually going to get the final answer, because the formula in this current form only gives you what cos of the angle is. It doesn't give you the angle itself. So you would then do inverse cos by pressing shift cos on your calculator and putting everything on the other side, or whatever you got as an answer to the other side over here. So all of this, you would put all of that in a bracket next to that inverse cos, and that would give you your final answer. That would give you the angle that is left there. Okay, so that is every type of situation that you could get for a question where you're meant to find the missing angle or side of a triangle. I tried to make that cover everything in that explanation. Hopefully that clarified a few different concepts and formulas. Just remember to always start with the question, is it a right-angled triangle? And you go from there. What are you then trying to find, the side or the angle? And if it's a non-right-angled triangle, you first of all start with the sine rule by applying the x test. And then if that doesn't work, you go and do the cosine rule and apply the v test. And just make sure you've memorized those two formulas and the two different versions of those formulas. Alright, I hope that helps, guys. If you enjoyed, please like and subscribe. Hit the bell for more notifications. Comment below with what you enjoyed or if you have any questions. And I'll see you in the next video.